Then we have first law of thermodynamics. First law of thermodynamics state, Gerard, if you provide heat to any system, then either the internal energy will increase, or it will do work, or it can do both. So if I provide heat, that is equal to delta U plus W. Okay, so first law of thermodynamics says that to a system, if we provide heat, then there will be change in internal energy, or it can do work, or it can do both. So whenever you give heat to a system, like basically heat given to a system will be positive, because I told you that if you give heat to the system, it will do work or internal energy will increase. So anything follows that will be positive. Other than that will be negative. So when we give heat, so that can be considered as positive. But if system is losing heat, giving is positive, so losing will be negative. Work done by, so heat provide, work is done by the system. So that will be positive. If you need to do work on the system, that will be negative. Gain in internal energy positive and decrease in internal energy would be negative. So now basically if I see that Q is equal to U plus W. Okay. And there are that this quantity is fixed. This is N CV delta T. Okay. CV is specific heat at constant volume. Okay. And CV plus CP is equal to R. Okay. CV plus CP is, no, CV plus R is equal to CP. That's what it is, right? CV plus R is equal to CP. CP value is more. So you can always see that CP minus CV is equal to R. It's not plus.
Yes,
These
sir.
values are clear to you?
Yes, sir.
And CP is specific heat at constant pressure. Okay. So to calculate Q, you have internal energy, which is always NCV delta T. Work done is different. Okay. So if I see work done is defined as integration PdV. Okay, integration of PdV. Is that clear?
Yes, sir.
Then you have number of process. So process number 1 is isochoric. Isochoric means volume is constant. Okay. If volume is constant, Gerard, then this delta V is 0. So if volume is not changing, then work done cannot be happen. Correct?
Yes, sir.
So I can simply say work done will be 0. So Q will be directly equal to delta U and Q value is equal to NCV delta T. So in case of isochoric, derivation is very simple, that because volume is constant, work done is 0. So Q is equal to delta U and Q will be equal to NCV delta T because delta U is NCV delta T. Is that clear?
Yes, sir.
Then we have the next process, isobaric. You understand basics of these processes, right? Isochoric, isobaric.
Yes, sir.
If you try to plot PV graph, volume constant will look like this. So you can see there is no area coming under it. That means pressure is constant. So if pressure is constant, we can take this out from the integration sign. So work done will be equal to P integration delta V. And small dV integration is delta V. So P is equal to V2 minus V1. Okay, work done is equal to P minus V1. Okay. Now,
Yes.
constant pressure line will look like this. So PV graph will be this. Now, if you need to find what is the heat given, so heat is equal to W plus delta U. So W is PV2 minus V1 plus delta U is NCV delta T. Okay. So that is how
Yes,
you
sir.
can write. This, if you further write, Gerard, we know PV is equal to nRT. Correct?
Yes, sir.
So if you multiply this inside, this is PV2 minus PV1. So this can also be written as nRT1, nRT2 minus nRT1. Plus this can be written as NCV T2 minus T1. Is that clear?
Yes.
So if you take N common from this, NR common from this, if you take kind of N common from this, NR common from this, so this is T2 minus T1. Plus if this is NCV T2 minus T1. Now if I take N T2 minus T1 common, so this will become R plus CV. And R plus CV is what? R plus CV is CP. So this can also be written as N CP T2 minus T1. So this can be written as NCP delta T. So work done is isobaric process comes out to be NCP delta T. Is that clear?
Yes, sir.
Sure, the entire derivation.
Yes, sir.
The next process we have isobaric done, isothermal done. Now we can do isothermal. Isothermal's PV graph will look like this. Okay. Isothermal means temperature constant. We know Q is equal to delta U plus W. Now Gerard, delta U is NCV delta T. Now isothermal is temperature constant. So in delta internal energy also change in temperature comes. So this will be zero in case of isothermal process. So whenever you see isothermal, simply close your eyes and put this temperature is going to be zero. So Q comes out to be W. So this is the case when Q is equal to W. Now what is W? W is integration PdV. You can write PV equal to nRT because temperature is constant. So I can write pressure is equal to nRT by V. So this can be written as nRT by V integration dV. Because temperature is constant, R is constant, N is constant. So you can take this out from the integration sign. So nRT integration dV by V. What is integration of 1 upon x? 1 upon x integration is ln x. So nRT ln of V. And if you put the limit V1 to V2, so this will come out to be nRT ln of V2 minus ln of V1. Log A minus log B is log A by B. So you can write nRT ln of V2 by V1. So in case of isothermal process, the work done comes out to be nRT ln V2 by V1. Is that clear?
Yes, sir.
Okay. So these are the couple of derivation for all these processes. Now you can, if I try to summarize in this, isobaric process, NCP delta T, work done is this. Isothermal process, delta U is 0, Q is equal to W, and nRT V2 by V1 or V final by V initial. If you see isochoric process, work done is 0, Q is equal to delta U, which is NCV delta T. So Gerard, while understanding the first law of thermodynamics, someone said that if you give Q, it will do work done and it will have a change in internal energy. But first law was not telling that heat will flow from where to where. This is number one was the problem, that heat will flow from hot body to cold body, or it can flow from cold to hot also. So that explanation was missing in first law. Also, first law was telling us that if you give heat, work done and internal energy will change, but when? Like if I provide when, that time factor was missing in that. So these couple of drawback was provided by second law of thermodynamics. Okay. So amount of heat that can be converted, so which is useful work information given by that how much work is useful. Then in condition, what are the condition when work can be converted into heat? So first law was simply telling that if you give Q, it will convert into work done. But some cases it's not possible. Your understanding, let's say you driving a car, your petrol is burning, you are getting some distances travel, and some work is done in friction and heat and all. But can I convert that friction, heat loss and kinetic energy to again regain the petrol? So that reversibility understanding was not there. So usefulness of work, first law was telling that, oh, this can be converted, right? Like, right, tomorrow Mr. Gerard come up with an invention that I have a car. If you travel, that heat lost by the tire and friction and the petrol burning, I'll all use that heat and all and recreate the petrol. So we can never have to purchase the another petrol. So that information first law was telling, but that was false. Okay. So Mr. Second law said that it is impossible to convert that can convert heat completely into work done. So if we have an engine, you provide some heat, it is impossible to convert that direct complete heat into work done. Like Q is equal to W. This is impossible to create, practically speaking. If you are converting Q to W, definitely there will be some heat will get lost. So this change in heat Q1 minus Q2, that is equal to W. So useful works comes out to be W by Q1. And that is the efficiency. Q1 minus W is Q1 minus Q2 over Q1. That is the efficiency of the engine. Are you able to understand? This is very complicated. Okay. If you're able to understand in first go, then you are great. You should take mechanical engineering. Okay. Are you able to understand that heat given cannot be directly converted into work done? So system will definitely eject some heat, that is Q2. And work done is basically this change in heat Q1 minus Q2. So I find efficiency of engine eta is equal to work done by Q1 and the work done is Q1 minus Q2 divided by the heat engine. So that is first statement of second law. You should know these statements as it is. So any heat engine which provides 100% efficiency, that is impossible. And don't even try. People have wasted millions of dollars in creating such engine and they failed because they are dealing with the law of thermodynamics. Law of thermodynamics are very powerful pillars. You should understand that and then only create it. If you try to follow second law or first law, then it is impossible. Like you cannot create. So we should not even waste time in doing all those things. Okay. Then self-acting machine is impossible, which we called as a PPM. People created a lot, but all are failed experiment because they were dealing with the second law of thermodynamics. It is impossible to transfer heat from a colder body to a hotter body without aid and external agency. This says that if I transfer heat from a temperature T1 to temperature T2, where T1 is less than T2, it is impossible. Like you are transferring heat from T1 lower temperature to higher temperature. That is impossible. Then you will see, sir, fridge. We have refrigerator. How does refrigerator work? We keep, this is an outer surrounding which is hot, and in the refrigerator we make the things cool inside it. So we are transferring heat from outside body to inside. No, you are adding the electricity also. So electricity is doing that work to transfer that. So it is very clearly mentioned, heat transfer from colder to hot body is impossible without an external agency. Over here, the electricity is the external agency.